Course 3, Lesson 96, we are looking at geometric measures with radicals. So being able to add and multiply radical expressions based on if we have common radicals. Well, to have common radicals, we need that to be able to add and subtract. And this idea of common radicals is, does it have the same radicand, which is the number underneath the radical symbol? Well, in this case, yes. We have a square root of 3 and a square root of 3, which means I have one root through here and one root through here, so I have 2 total. It's just like if we were to say, I have x plus x. Well, that means I have the same variable, so I have like terms, so I have 1x plus 1x equals 2x. We don't change that x. We don't change it when we're adding. We keep the x, but count up how many I have. Same with our radicals. So if I have root 5 plus root 4, well, it's going to stay as root 5 plus root 4 because we don't have common radicals. We don't have the same number underneath the radical symbol. But if we have 3 root 5 plus 3 root 5, I have 3 of them here and 3 of them here, so I would have a total of 6 root 5, which works. Now, looking at some other examples, we want to find the perimeter and area of this rectangle. Well, unfortunately, currently this rectangle is kind of skewed, so we can't just count up sides to find the perimeter and count and multiply for the area. We actually have to use the Pythagorean theorem to say, what is the hypotenuse of this little imaginary triangle that I can create off of our rectangle? So, if we do that, then we can say, oh, well, that just means that I have a 3 by 3 triangle and I need to find the hypotenuse. So we do 3 squared plus 3 squared, I'm just putting it in the Pythagorean theorem, equals c squared. So I have 9 plus 9 equals c squared, so 18 equals c squared. Well, I still need c, so I'm going to take the square root. And I have c equals the square root of 18, but I can take 18 and simplify, saying that's 9 times 2 and 3 times 3 for the 9. So I have 3 times 3 times 2, just like we've done before. And I can circle and pop the 3's. So I have 3 root 2 equaling c. So we have this side length here of 3 square root of 2, and this one is also 3 root 2. Now we just need to find this other side length of the triangle, and I can make an imaginary other right triangle with side lengths of 2 by 2. So I would say, okay, 2 squared plus 2 squared equals c squared. So 4 plus 4 is 8 equaling c squared, and I take the square root. Well, 8 can be broken into 2 and 4 and 2 and 2. So I have 2 times 2 times 2 equaling c squared, or sorry, just c. So that means that I can circle and pop some 2's, and we have 2 root 2 for this side here. 2 root 2 and 2 root 2. Well, if we are trying to find the perimeter, that means that I have to add up all of those sides. 2 root 2 and another 2 root 2. And then we have my 3 root 2 and 3 root 2. Well, good thing, because we have all common radicals. All of them have the square root of 2 as part of it. So I just need to say I have 2 plus 2 plus 3 plus 3, which means I have 10 square roots of 2. For the area, now I get to multiply, so it doesn't actually matter if we have common radicals. We are going to multiply 2 root 2 times 3 root 2, because we do base times height. And remember, we multiply outside of the radicals, so 2 times 3 is 6, and inside the radicals, so we have times the square root of 4, but the square root of 4 can be simplified to 6 times 2, which is 12. So we have 10 root 2 units for the perimeter, 12 units squared for the area. Now if we go on, we can use the same idea for some other problems. Find the length of the hypotenuse. Well, this is a right triangle, so we are going to say I have the square root of 3 squared plus 1 squared equaling c squared. So if we have the square root of 3 squared, well, that's like having the square root of 3 times the square root of 3. Well, that's just the square root of 9, which is now just 3, plus 1 squared, which is just 1, equaling c squared. So I have 4 equals c squared. I take the square root, and the square root of 4 is just 2. So my hypotenuse is 2. So I would say if I want the perimeter of this triangle, I'm not going to need to add 2 and 1 and the square root of 3. Well, 2 plus 1 I can add because those are like terms. They're just numbers. They're just rational numbers. So I get 3 plus the square root of 3. And the question is, can I add those together? The answer is no, because our original 3, this whole number here, doesn't have a root 3 attached to it. They don't have common radicals. So we have to leave it as 3 plus root 3 units. Similarly, we can do this with other triangles. And we have a couple other examples of this. So find the area of the triangle and the perimeter of the triangle. Well, let's start with the area. And we have to do base times height. And we're going to divide it by 2. Well, we have 2 root 5 divided by 2. Well, that's just the square root of 5 units squared. That was pretty easy. Now let's find the perimeter. But to be able to find the perimeter, I need to find the hypotenuse. So let's use the Pythagorean theorem and say 2 squared plus the square root of 5 squared equals c squared. So we get 4 plus, well, this is going to end up being the square root of 25, which is just 5, equaling c squared. So c squared equals 9, which means when I take the square root, I get c equals 3. So to get the perimeter, I have to do 3 plus 2 plus root 5. The only things I can add together are the 3 and the 2. So we have 5 plus root 5 units. And just like before, we can't add those because they're not common radicals. All right. So if we have the area of the rectangle, perimeter of the rectangle, well, the perimeter is going to be, I'm just going to add a bunch of these together, right? 2 of the 2 root 3's and 2 of the 3 root 3's. So I have the perimeter being 2 root 3 plus 2 root 3, and then a 3 root 3 plus 3 root 3. Can we add these together? Yes, because they have common radicals. So I just need to say, well, I have 2 plus 2 plus 3 plus 3, which is 10 root 3 units. To get the area, I need to multiply and say I have 2 root 3 times 3 root 3. Well, I can multiply the 2 and the 3 to get 6 times 3 times 3 is the square root of 9, so I have 6 times 3, which is 18 units squared. Okay, so even if we have radicals as our measurements for rectangles, triangles, that's okay. We can do it. All right, so these are a couple of other examples that you can try. Okay, just remember you're going to have to use the Pythagorean theorem to do them. Okay, so like if on the second example, you would need to create a triangle right here to say, well, this side is 1, this side is 2, so I have 1 squared plus 2 squared equals c squared, and find our side length. And what's nice about this is we actually have the same on all of those. So when you find out that it is the square root of 5, well, then you can just say I have 4 root 5 for the perimeter and 5 is the area. So you can try it on your own and figure that out. And very similarly, you can do the first one up there. Well, I hope this is helpful for your homework.